Welcome to BW tutorials. Let us see resistor connection of resistor in series and parallel. Also voltage divider rule and current divider rule. Now resistor connection in series. Also resistors connection in parallel. What is connection of resistors in series? Let's see. When resistors are connected in serial manner such a way, it is known as series connection. Let us name these resistors as R1, R2, R3 and connected to a voltage source. Again, what is connection of resistors in parallel? If the resistors are connected in such a manner, then it is known as a parallel connection. Let us name these resistors as R1, R2, R3. All these are connected to a source. Then what happen when we connected resistors in series manner and in parallel manner? Let us see now. While connection in series, the current flow at each resistor is equal now, and voltage is different at each resistor. If we name A, B, C, D points, then voltage is divided such a manner. Now first point, current at all resistors are equal, and voltage at different resistors are unequal or not equal. The voltage is divided in series connection such a manner the total voltage equals to here V1 plus V2 plus V3. From Ohm's law, V is equals to IR. Now write this formula into such a manner. V is equals to IR, V1 is equals to I1 R1 plus I2 R2 plus I3 R3. From point 1, current at all resistors are equal. Now hence I is equals to I1 equals to I2 equals to I3. So all combo, write I1 is equals to I plus R1 plus I2 is equals to I R2, I3 is equals to I R3. From this, while we taking I as common, now R1 plus R2 plus R3. From both sides, the cancellation of I. Now R is equals to R1 plus R2 plus R3. For n number of connections are there, R1 plus R2 plus R3 so on Rn. So if we connected series of resistor, then this formula is required. Again, in parallel connection, here the voltage is equal at every resistor, and the current is going to divide. I going to divide at I1, I2, I3. Now if we take parallel connection, voltage at all resistors are equal in parallel connection. Parallel connection. Again, current is different or divided in each resistor such a way I is equals to I1 plus I2 plus I3. From Ohm's law, if we write I is equals to V by R, then this formula is converted as V by R, V1 by R1 plus V2 by R2 plus V3 by R3. Hence, voltage at all resistors are equal in parallel connection. So V is equals to V1 equals to V2 equals to V3. Now write this formula as V by R equals to V by R1 plus V by R2 plus V by R3. Now V by R, V is common at all terms, R3. Both the sides we are going to cancel. Now 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. Suppose if we have n number of connections in parallel, then 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3, so 1 by Rn. This formula is used when the resistors are connected in parallel. This formula is used when the resistors are connected in series. What is voltage divider rule and current divider rule? Let us see now. In series connection, the current at all resistors are equal such a way the above example. Then I is equals to I1 is equals to I2 is equals to I3. Then from Ohm's law, only V is different at each resistor. Now V is equals to IR, I is equals to V by R. V by R equals to V1 by R1 equals to V2 by R2 equals to V3 by R3. Now if we want to calculate a voltage at a particular resistor, then this voltage divider rule is more important. Such a way, if we want to calculate voltage at resistor 1, then we use up to formula here. Such a way, V1 is equals to V by R into R1. Then what is V? V is total voltage or applied voltage. R is total resistance. What is R1? R1 is resistance resistor 1. Suppose if we want to calculate voltage at resistor 2, then V2 is equals to V by R into R2. If we want to calculate voltage at resistor 3, then V3 is equals to V by R into R3. So such a way voltage divider rule is used. Now current divider rule. In parallel connection, voltage is same at each resistor in parallel connection. Such a way V equals to V1 equals to V2 equals to V3. Again V is equals to IR from Ohm's law. If we apply this formula to here, then V is equals to IR, I1 R1, I2 R2, I3 R3. If we want to calculate current at a particular resistor, let at resistor R1 what is the current flowing. If you want to calculate it, then I R equals to I1 R1, use up to here formula. Then I1 is equals to IR by R1. What is I? I is total current. What is R? R is total resistance. What is R1? Resistor 1. Suppose if you want to calculate current flowing in resistor 2, then I2 is equals to IR by R2. Again I3 is equals to IR by R3. So such a way, if you want to calculate current flowing through particular resistor, then current divider is useful.